Everybody, welcome back to our next tutorial on topic inheritance. I am Dr. Nischay Bahl, and in this tutorial we'll be studying assess specifiers. Friends, as you know, in previous tutorial we studied about inheritance, what is inheritance, example case studies of inheritance, and benefits of inheritance, and what is the concept of base and derived class and how they are declared. We gave 3 to 4 examples in which the concept was made clear. And another very important topic in inheritance is assess specifiers, and it's always a very important topic from student point of view, because unless until you don't understand this topic, it's difficult to understand the concept in detail. So let's see thoroughly what is assess specifiers, what are the types of it, and we'll do example programs also. So what is an assess specifier? Assess specifiers are used to identify the access rights for data and member functions of the class. So they're used to restrict the access to the data members of a class. That means we are implementing basically data hiding or data abstraction by using access specifiers. That's when we say C++ puts data hiding or it puts data abstraction. That means we are facilitating that features with the help of access specifiers. In C++, access specifiers are of 3 types: public, private, and protected. And if we don't declare any type of access specifier, the default access specifier is private. Always the default access specifier is private. So if we declare, well and good, and if we don't declare anything, and if we leave it blank, that data members are taken as private by default. So in the table given below, we can see the 3 access specifiers and the brief definition. Let's go through them. So private access specifier, that means class members declared as private can be used only by the member functions and the friends of the class. That means only the member functions and the friends of the class can use the private members. And what are the protected members? Class members declared as protected can be used by the member functions and friends of the class. Additionally, they can be used by the classes derived from the class. So that is the difference. Private members cannot be used by the derived classes, whereas protected members can be used by the derived classes also. Whereas public members can be used by any function. So what is the importance of access specifiers? Access control helps prevent you from using objects in the way they are not intended to be used. So they help in implementation data hiding and data abstraction. So intentionally or unintentionally, some data member is not misused. So that is the main purpose of access specifiers or access control. So a derived class can access all the non-private members of the base class. Thus the base class members that should not be accessible to the member functions of derived class should be declared as private, because whatever we declared as private cannot be accessed outside the class. Okay, so we can implement data hiding by this methods. So we can summarize the different access specifiers according to who can access them in the following way. For example, in the table given below, you can see public, private, and protected. So within the same class, public are also accessible, protected are also accessible, and private are also accessible. And within the derived class, public members are accessible, protected are also accessible within the derived class, whereas private are not accessible within the derived class. And outside the class, that means it may not be derived class. Okay, outside the class means within the function main. Public members are accessible, protected members are not accessible, and private members are not accessible. That means within the same class we can access all the 3 members, public, private, and protected. And within the derived class we can only access public and protected members. We cannot access private members. And outside the class we can access only public members and not protected and private. A derived class inherits all the base class methods with the following exceptions: constructors, destructors, and copy constructors of the base class. Okay, overloaded operators of the base class. Okay, so these are the exceptions, the friend functions of the base class. Except these 3 exceptions, a derived class inherits all the base class methods. That means these features cannot be inherited. While deriving a class from the base class must be inherited through public, protected, or private inheritance. We have to declare that in syntax. We saw in the previous lecture. We hardly use protected or private but public inheritance is very, very commonly used. While using different types of inheritance, following rules have to be applied, because you have to be very clear okay, what is your protocol hierarchy, what is your order of derivation of the classes, and what members are to be used in which class, and which class the access has to be controlled. So you have to be very particular about that rules and regulations. So in this diagram given below, we can very simply see, so on the top it's public inheritance. Whenever we publicly inherit a class, so this is a base class, this is a derived class. The public member of the base class becomes the public members of the derived class. The protected members of the base class becomes protected members of the derived class. And in the case of protected inheritance, the public and the protected members, both of them become the protected members of the derived class. Whereas in the case of private inheritance, both public and protected members of the base class become the private members of the derived class. So both in private and protected inheritance, public and protected member becomes protected and private respectively. Whereas in the case of public inheritance, public becomes public in derived and protected becomes protected in derived. So there's a theory written here on the right hand side. You can go through that. So it's shown in a better diagrammatical method also. You can see this is a base class and this is a derived class. So whenever we do public inheritance, so this protected base and protected public base, protected base becomes protected base member here in the derived class, and public base, which is a public member of a base class, becomes public member of the derived class. So as I told you, the protected members of the base class becomes protected member of derived class, public member of the base class becomes public member of the derived class. So this is public inheritance. And in the case of private inheritance, both protected and public members of the base class become the private members of the base class. You can see these two members are being shifted here, shown in a dotted box. And in the case of protected inheritance, both protected and public members become the protected members. You can see this box also here. So next we are showing you a few example programs, and let us go through this program. It's a tested program. You can see the output also. This is a program of public inheritance. Here I have taken one class, students. I have taken one class that is base, and in that base class we have taken three members A, B, C as private, protected, and public respectively. We have derived one class from the base class, and we have taken again three members X, Y, Z as private, protected, and public respectively. Then we have written one derived read function which reads B and C, that is protected and public members of the base class. Then we have written one derived show function which prints B and C, which are the protected and the public members of the base class. And in the main program, we can see we are creating an object of a derived class. Whenever you write derived public D, that means D is an object of class derived public. So what is derived public? Derived public is a class which is publicly derived from base class. So whenever you write this statement, class derived public base, that means this class is publicly derived from base class. So this is a public inheritance. Okay. So when I will write D dot A, so this will result in an error because A is a private member and private members are not accessible outside the class, as I told you. So I've written this line in comments. If I write D dot B, that also results in an error because protected members are not accessible outside the class. If I write D dot C, that's accessible because that's a public member and it becomes a public members of the derived class. So D dot C is accessible. D dot X is again not accessible because X is a private member and private members are not accessible outside the class. Similarly, D dot Y will also result in an error because it's again protected members not accessible outside the class. Okay, D dot Z, that will result into 10. That will be a true statement because that's a public member of the derived class. And then we are calling D dot derived read and show, which are the public member functions of the derived class, and they can be called here because they're public members, and within that public members we are assessing protected and private members respectively. So we are not assessing B and C directly here in the main program. We are calling derived read and derived show, and there within we are using B and C function. So you can see the output once we enter the value of the protected and public members as 23 and 34, we get B as 23 and C as 24. That means the members were accessible through the public member functions in the derived class. So this is a very simple program. You can always make a very simple programs. We don't need to mug the programs. It's a very simple made program. So if you make this one program, you can very easily extend the other two programs, that is on private inheritance and protected inheritance. So let's see on private inheritance. So in private inheritance, you can see there's a difference in this line here. Let's come to this line. Once a rate class derived private column private base. This means this class derived underscore private is privately derived from class base. So in the case of private derivation, we knew that protected and public members becomes a private member. So that means again we have base class of 3 data members ABC, private derived private of XYZ, and this coding is same as the previous program. And here if we see derived private, we are creating an object D. So again D.A is not accessible, as I told you. D.B is also not accessible, as I told you earlier. D.C is also not accessible because these members become the private members, and private members are not accessible outside the class. And D.X is also not accessible because X is a private member. D.Y is also not accessible because it's a protected member. D.Z is accessible because it's a public member, and you can call it as D. Derived read and derived show. You can call that again. You can see if you enter the value of protected and public members as 23 and 24, you get the respective outputs. So this is about private inheritance. And the last case is protected inheritance. So again, we're declaring one base class with 3 data members, A, B, C as private, protected, and public. We're using one derived class, which is protectedly derived from base class. So it's example of protected inheritance. Okay, so this keyword protected is written here. Again, we are using 3 members X, Y, Z as private, protected, and public. Okay, and in the protected, we have shifted that to functions which we wrote in the public declaration of the previous program. We shifted that to functions here in the protected, because in the case of protected inheritance, the protected and the public members of the base class becomes the protected members of the base derived class. So we shifted that to functions here, and in the public we declared a variable Z, and we are calling one function in public, and that function is calling that protected members here. So we'll see with an example. We are creating an object of derived class D. So D.A is not accessible, of course not accessible, as I told you earlier. D.B is again error statement. D.C is all the error statements I put in my comments. D.X is also not accessible. D.Y is also not accessible. D.Z is accessible because it's a public member, and D.SS protected. Now what is SS protected? See, SS protected is a public member of derived class. That public members you can always access outside the class. Okay, and that public member is calling two protected members, and protected members can be accessed within the class. Okay, they can be accessed also within the derived class also. So we are calling derived read and derived show within the access protected. So whenever you call these two functions, they respectively assess B and C. Whenever you call derived read, it says B and C. Derived show, it says also B and C. They're assessing the private, protected, and the private members. They're reading them and printing them respectively. And very important, students, you must note down here, if we write D.derived read directly, that will result in an error. D.derived show directly, that will result in an error, because protected members not accessible outside the class. Okay, because all these are protected members, they are not accessible outside the class. So we have called that member functions through that access protected function, which is a public function, and we are assessing the public function outside the class, and that public function is calling that protected member functions of that class. So again, you are getting the respective output, value of B as 23, value of C as 34. So this is access specifiers, and as we have seen, access specifiers play a very important role in the implementation of data hiding as well as data abstraction. And anyone who wants to do programming in inheritance, it's very important to understand the concept of access control or assess specifiers or assess control specifiers. So friends, thank you very much. This was Dr. Nischay Bahl, and in the next tutorial, we'll see what are the types of inheritance and example programs on that. So thank you very much. Happy learning. Thank you all.